This is based off of data. Whose data? NASA's data. It's just that they don't want to talk about it, so they leave it to other people to talk about it. And there are two different catastrophic events that we present in the documentary. One is natural. The other isn't. Now, I don't want to spoil it for those people who haven't seen the film, but, you know, this is when it starts to get really, really deep and heavy. So if they're only looking at the solar wind, they are not really pursuing these fields of study, which have strong data to indicate the loss of the atmosphere was due to something else entirely.
Yeah. Do we know how thick the atmosphere was in the ancient Mars when it was blue like the Earth? Was it as thick as our atmosphere?
I don't know specifically, but I think that the take home is yes, it had to have been. You know, liquid water can only exist under certain conditions. Because the pressure, the atmospheric pressure is so low, liquid water cannot, H2O cannot remain in liquid form for very long under present Mars conditions. It really required a thicker atmosphere, much more like the one we have here on Earth. Now, as to whether it was equally as dense or almost as dense, I don't know the details on that. But you have to think, if liquid water was able to form in large bodies, then and there was a lot of oxygen on there, then it was certainly a lot closer to what we have here on Earth right now.
Yeah. So tell me, just remind everyone I guess the details of in your film. What are the hypotheses for how we've lost the atmosphere on Mars?
All right. Well, one of them is a natural explanation and not well understood by many people. Not many people are not aware of this. Many people are not aware of either one of these. But there is something called electrical discharge. All right. Think of it this way: when you zap your finger on the door handle when you grab it, right? Zaps you.
Yeah.
Lightning. Okay. This is electrical discharge. That's all that it is. You have a difference in charge, positive and negative, and the electricity wants to discharge between the two. That's what causes lightning. Electrical discharge between two bodies, the clouds on the ground, the door handle, and your finger. This is a scalable phenomenon. You can have like the thing that zaps you on the door handle. That's a tiny lightning bolt. Okay, and then when you look outside during a storm, you see a big lightning bolt. Now think of it this way, Adnan: if you have two planetary bodies that happen to get close enough to one another, and if they are of different electrical charges, then they can discharge between the two of them. Okay? So we're talking about a planet-sized lightning bolt. All right? That's scary. And a planet-sized lightning bolt, I have another image here to show. Okay, so share screen. A planet-sized lightning bolt, Anon, just might have the power to create a large enough shock wave to blow the atmosphere off of the planet. Now, if you're looking at Mars here, you see this big scar right here?
Yeah.
Geologists want to say, well, this was caused by flooding. Volcanologists want to say it was caused by volcanoes. This is not either one of those. This is an electrical discharge scar. Now, how do we know this? We know this because this exact scar, this signature scar, it's kind of funky, was reproduced in a laboratory with electrical discharge on just a small little plate with some sand on it. You zap it a certain way, and it produces this funky looking shape. Now, here, this thing here is the size of the United States. That's one hell of a big zap. So, this mainstream scientific community does not really want to factor in that line of research because it's not, it presents a lot of problems, because what neighboring planetary body would have gotten close enough to Mars? Well, if you think of it this way, our solar system, there's reason to believe it wasn't always as neat and as stable excuse me, as it is right now. Planets could have been in different configurations. There could have been other planetary bodies, rogue planets coming in and out of the solar system. Things might have just been moving around a little bit differently. But there's also compelling evidence that maybe it wasn't a nearby or a passing by planet, but that it was the sun itself through a solar outburst, a plasma event. Okay? And think of it this way: the aurora borealis, the northern lights we're familiar with here on Earth, that is an interaction between the sun's solar wind, the output of the sun, and the Earth's magnetic field. It produces these cool, wavy, trippy lights. That is a plasma interaction. Now, if you imagine that on steroids, it might produce one hell of a big plasma discharge that could cause a scar like this. So something that big, and think of it this way: where did all that material go? If you look at any rover photograph, it's always just littered with rugged-looking rocks just everywhere. It's like something blew up and scattered all over the place. And arguably, due to the large number of impact craters on the planet and this giant scar, a lot of this material is just blown all over the place. And if you think about it this way, how many Mars meteorites do we actually have here on Earth? Meteorites were blown off the surface of this planet so fiercely that they land here on Earth. And we don't really have hardly any meteorites from Venus. We might have one or two, but we've got a shit ton of Mars rocks.
Wow.
Okay? Something catastrophic happened, blew the planet to hell, and all that shit just went out into space.
Yeah.
And maybe the two moons that are orbiting right now also came from Mars. Like something blew it up and it just started orbiting around. So that's one hypothesis, and there's evidence to support that.
Yeah. That's it's right in your face, isn't it? Like, look at that. It's huge.
It's frightening.
Yeah. And so what's the second one?
Well, let's just tease it, shall we?
Yeah.
For those people who have seen the movie Oppenheimer, the Christopher Nolan movie that came out a couple years ago, regarding the development of the first atomic weapon, there's a scene in that movie between Matt Damon's character and Cillian Murphy's character, who, he was playing Oppenheimer. And before they run the first test, Matt Damon asks Cillian Murphy, what are the chances that we make our first atomic detonation and it ignites the atmosphere and thus kills all life on Earth? What are the chances that that's going to happen? And Cillian Murphy responds that there is a near zero chance. Not quite zero, but near zero. So this caused a little bit of concern. We don't know for sure, but we're kind of sure, but not 100%. All right? They were afraid of igniting the atmosphere. And the evidence that Dr. John Brandenburg has collected Well, it indicates something very similar to that happened on Mars. So there's a lot more to it, but I would encourage you to watch the film because it explains it all. There's a lot to it, um, you know, and we'd be here too long trying to go over it all. But there's data there, and who has collected that data? NASA has collected that data. They just don't want to talk about it.
Hmm. So what's in the atmosphere for a nuclear weapon to, get it on fire and for it to burn into nothing?
The atmosphere is a collection of molecules, just like any other matter. When we think what is in a nuclear weapon, we've got plutonium, we've got uranium, sometimes we have thorium, these types of heavy elements. And it is when we provoke an explosion that sets off a chain reaction that splits atoms, okay? And due to the close proximity of the atoms and thus neutrons in these heavy elements, plutonium and uranium, it is easy, relatively speaking, to set off that chain reaction. Okay? But when we start talking about an atmosphere, all of those molecules and atoms are not so close together. So it requires a whole lot more energy. A whole lot, to the tune of, 10 to 100 times the energy of the impact that is credited for killing the dinosaurs. We're talking about a whole lot of energy.
Mm. So what is the way that we can bring back the atmosphere on Mars?